Hello, Silver and Gold Stars of 337 Rangers Cadets. Today we are going to be learning lesson EOM322.02, which is how to calculate magnetic declination. So we're going to start off with the introduction. The objective of this lesson is to calculate magnetic declination and be able to set it on a compass. The importance further is that this knowledge provides the cadet with confidence when navigating on a bearing. Not accounting for declination may affect navigation, and for every 1 degree of error in declination setting, a person would be approximately 52 meters off for every kilometer traveled. Teaching point 1 is a review of magnetic declination and the three norths. Magnetic declination is the difference between true north and magnetic north. True north, on a map, is the direction of a line of longitude which converges on the North Pole, while magnetic north is found on your compass. Each map has a declination diagram that shows true, grid, and magnetic bearing of any line within the area of the map. The difference between true north and magnetic north changes each year due to the shifting magnetic pole. Further, there are only 2 lines in the northern hemisphere where magnetic and true north line up to equal a declination of 0 degrees. One of those lines runs through central Canada, while the other line runs through Russia. Continuing on with teaching point 1. Grid magnetic angle. This is the horizontal angular difference between grid north and magnetic north. This is also the number that is applied when converting from magnetic to grid bearings. Next is the annual magnetic change. Magnetic north, which is on your compass, continuously changes due to the dynamic forces on the Earth. So, that means that every year there needs to be an adjustment made to obtain the correct grid angle. To know the amount of adjustment, one can use the declination diagram, which is found on every map. Changes or adjustments to a compass to compensate for the annual magnetic changes is known as setting the declination. Magnetic change needs to be considered so that navigation is not negatively affected. Every map provides the necessary information to calculate the declination, which is usually found in the margins of the map. For the last part of teaching point 1, we are going to talk about the three norths, starting off with true north. True north is located at the top of the Earth, where the North Pole is geographically located. This is the point at which the Earth rotates on its axis and where all of the lines of longitude meet. On a map, true north is represented by a star, or plurus. Next is grid north. It is the north indicated by the grid lines, also known as the eastings, on a topographical map. Eastings are lines that run parallel to each other and will never meet at the North Pole. Because of this, grid north points off slightly from true north. On a map, grid north is represented by a square. Finally, there's magnetic north. It is the direction in which the compass needle points. It points to the magnetic pole, which is located in the Canadian Arctic and is slightly different from true north. On a map, magnetic north is represented by an arrow or a half arrowhead. Now it's time for the confirmation questions of teaching point 1. Although I will be reading the questions right now, you'll be able to answer them during the Kahoot after the lesson. Question 1. Explain true north. Question 2. What symbol on a declination diagram represents magnetic north? And question 3. What is annual magnetic change? The next part of the lesson is teaching point 2, which is to demonstrate, explain, and have the cadets practice calculating magnetic declination. The first step is to locate the declination diagram and its information. Calculating current declination uses the information provided by the declination diagram on each map and the information which is directly printed underneath the declination diagram. Most often, this information, along with the diagram, is found on the right side of the map in the margins. Moving on to calculating. To calculate declination, you need to use the angle between magnetic north and grid north. For this, we will be ignoring true north. This is done because bearings taken from a map use grid north as their point of reference. The annual change noted under the declination diagram will either be increasing, which means the declination is getting larger, or it will be decreasing, which means it's getting smaller. The annual change will then either be added or subtracted from the declination printed on the map to get the current declination. This will further be explained in the next slide. Next, I'm going to be going over the overall steps for calculating declination. These are just overall steps. The following slides will give you detailed steps on how to properly calculate declination. But let's start with this first. First off, the degree system of bearings shares some structure and terminology with units of time. For example, 360 degrees in a circle is written as 360 with the degree symbol. 60 minutes in a degree is written as 60 with an apostrophe. And 60 seconds in a minute is written as 60 with 2 apostrophes. Step 1 is to identify how current the map is. In order to do so, you need to identify the current year. That is the year in which you are calculating declination. For example, if I were to be calculating declination for this year, I would be using the year 2020, as it is the current calendar year. Next is to identify the year of declination information. Once again, this information is found under the declination diagram, and it is defined as the approximate mean declination. Finally is to record the difference in years. That is, the current year, for example, 2020, minus the approximate mean declination. Step 2 is to determine how much declination has changed since the map was current. In order to do so, you need to multiply the difference in years by the annual change. This information again will be found under the declination diagram. Third is to update the map declination with the amount of change calculated. In order to do so, you need to determine if the annual change is increasing or decreasing. This information is found once again under the declination diagram. Then, you need to add or subtract the annual change from the original declination. If the change is increasing, then you are going to add to the map declination. And if the change is decreasing, then you're going to subtract from the map declination. Lastly is to set the current declination on the compass. In order to do so, you need to determine if declination is east or west. This is done in order to determine what direction the declination must be set on a compass. East or west is determined by looking at the declination diagram and identifying true and magnetic north. The side that magnetic north falls on represents east or west. If magnetic north falls on the right side, it is east. If it falls on the left side, it is west. Finally is to set the calculated declination on a compass. There is a declination adjusting screw on the back of the compass. I will attach a video further explaining how to adjust the declination on a compass.
First, turn your compass over. Second, find the small declination adjustment screw that usually looks something like this. Third, insert the key that's usually connected to your compass's lanyard and insert it into the adjustment screw. Fourth, turn the key until the declination indicator is the correct number of degrees east or west of 0. After setting your declination correction, you won't need to account for magnetic declination again until you move to a new location with a new magnetic declination.
Now I'm going to show you a declination diagram sample. This example will use east declination. Before doing any calculations, I want to show you that there's a diagram on the right-hand side of the screen. The diagram shows that there is a mean magnetic declination of 19 degrees and 52 minutes east of grid north. We know that it is east of grid north because magnetic north is to the right. We also know that there is an average annual change of 7 minutes, which is decreasing. This information is given at the bottom of the declination diagram. Lastly, we know that the approximate mean declination is from the year 1991. Now we can start with our calculation. Step 1 is to calculate the difference between the current year and the year of the declination information. We know that our current year is 2020. And we also know that the year of the declination information is 1991. Subtracting that number from 2020 will give us the difference in years, which is 29. Step 2 is to multiply the difference in years by the annual change. In order to do so, we are going to take the difference in years, which is 29, and the annual change, which we know is 7 minutes. Multiplying those two numbers will give us the total change, which is 203 minutes or 3 degrees and 23 minutes. The next slide will show you how to convert from minutes to degrees and minutes, which you will need for the third step of this calculation. As we know from the previous slide, 203 minutes is converted to 3 degrees and 23 minutes. Further, there are 60 minutes in a degree. 60 minutes goes into 203 minutes 3 times. That's what gives us our 3 degrees. What is left over is 23 minutes. So, the converted number you are left with is 3 degrees and 23 minutes. Now it's time for the third and final step. We know from the diagram that the annual change is decreasing, so we know that it will be subtracted from the original declination. The original declination, as shown on the diagram to the right, is east 19 degrees 52 minutes. What we are then going to be doing is subtracting the total change, which we know is 3 degrees and 23 minutes. This gives us our current declination, which is east 16 degrees and 29 minutes. This tells us that the magnetic needle on a compass will point to the east of grid north by 16 degrees and 29 minutes for the area depicted on the map with this declination diagram in 2020. Now we're going to be looking at an example with west declination. All of the steps will be the same, just that the declination diagram information will be different. So, the diagram on the right of the screen shows that there is a mean magnetic declination of 13 degrees and 18 minutes. This is to the left-hand side of grid north, so we know that is to the west of grid north. Also, we can see that there is an average annual change of 1.7 minutes. However, this time, the annual change is increasing. Lastly, we can see that the approximate mean declination is from the year 1993. Now we can move on with our calculation once again. Step 1 will again be to calculate the difference between the current year and the year of the declination information. The current year, once again, is 2020. Subtracting the year of declination information, which this time is 1993. This gives us a difference in years of 27. Step 2 will once again be to multiply the difference in years by the annual change. The difference in years, as we know, is 27, and the annual change this time is 1.7 minutes. Multiplying these two numbers will give us the total change, which is 45.9 minutes. We don't need to include degrees because, as we know, 45 is lower than 60 minutes. Now, once again, we will be moving on to the third step of the calculation. We know from the diagram that the annual change is increasing, so it will be added to the original declination. We know the original declination is west 13 degrees 18 minutes, and we know that the total change is 45.9 minutes. Adding these two numbers gives us the current declination, which is west 13 degrees 63.9 minutes, which we would then round up to 64 minutes. However, we first need to look at our minute side. Since our minutes are above 60, we would subtract 60 from the minutes, leaving us with 4 minutes. Those minutes would then be converted into 1 degree, which we will add to our degrees. This will give us our final current declination, which is west 14 degrees and 4 minutes. This tells us that the magnetic needle on a compass will point to the west of grid north by 14 degrees and 4 minutes for the area depicted on the map with this declination diagram in 2020. We have to round minutes up or down as required during calculations. For example, if you are at or over 0.5, you would round up. And if you are below 0.5, you would round down. You might have already noticed that when subtracting, there are times when the equation cannot be completed without borrowing from the next figure in the line. Let's use the following example. Say we had 13 degrees and 12 minutes minus 45 minutes. To complete this equation, 1 degree, or 60 minutes, must be borrowed from the 13 degrees to allow subtraction from the 12 minutes. When borrowing a degree, remember 1 degree equals 60 minutes, reduce the degree portion by 1 and add 60 minutes to the minute numbers. This looks like this. Let's say we originally had 13 degrees. Minus 1 gives us 12 degrees. We would then add that 1 degree, or 60 minutes, to the 12 minutes, giving us 72 minutes. Thus, 12 degrees and 72 minutes minus 45 minutes gives us a final answer of 12 degrees and 27 minutes. This equation can now be completed as seen above. Now for the confirmation questions for teaching point 2. Once again, these questions will be able to be answered at the end of the lesson during the Kahoot. Question 1. Where is the declination diagram found on a topographical map? Question 2. How many minutes are there in a degree? And question 3. When the annual change is decreasing, what difference will this make to your calculations? The third and final teaching point is to calculate magnetic declination using east and west declination examples. The objective is to practice calculating magnetic declination, and there's only 2 simple instructions. First is to complete the worksheet on the next slide, and second is to log on to the Kahoot to answer the questions with your fellow silver and gold stars. Remember that completing the worksheet ahead of time will definitely give you an upper hand on completing the Kahoot questions faster. This next slide is the declination worksheet. Feel free to pause the video at any time to write down the questions and then fill in your answers. Remember, there are 2 slides, so in total there are going to be 8 questions. This has been EOM322.02, Calculate Magnetic Declination. Now you have time to answer the confirmation questions, the magnetic declination worksheet, and wait for the Kahoot game pin to go out via Remind at 8 p.m.